Hello everyone, in this video we will be discussing quadratic equations. A quadratic equations is a second degree equation that takes the form ax squared plus bx plus c, which is equivalent to 0. So unlike the linear system or linear equations must not have any exponents in any terms of its system. But in quadratic equations, it is a second degree equation because, as you can see, the highest degree of its terms or the highest exponent of each term is raised to 2 or squared. And where a, b, and c are constants, and a must not be equal to 0. So this is the definition of a quadratic equations. Now, we have two types of quadratic equations. We have the complete quadratic equation and we have the incomplete quadratic equations. So complete quadratic equation takes the form of this one, which has all the terms that is needed from the highest exponent, which is squared. We also have coefficient of 1 or the exponent of 1, and we also have the constant. We also have the incomplete quadratic equation, which just takes the form of this one. We have just the highest exponent or ax squared plus the constant, and we don't have the bx anymore. So if you can see a system or equation that takes this form, this is still under quadratic equation. However, this is what we call the incomplete quadratic equation because we don't have the middle term. There are four types or four steps or four methods in solving algebraic methods in solving quadratic equations. We have four algebraic methods. This is what we call factoring method. We also have the extracting the square root method. We also have the completing the square method, and as well as the formula method. So for this video, we will be discussing each of these methods. We will be trying to solve quadratic equations under these methods. So first, let's discuss the factoring method. So factoring method is the equation that the equation must be in the complete quadratic equation with the left member equal to 0. So for this one, as you can see here, we have the example, find the solution set of the equation 2 over x plus 4 is equivalent to x plus 3. So by seeing this one, this is not a complete quadratic equation, right? Because we don't take the form ax squared plus bx plus c. So how can we solve this one using factoring method if it does not conform with its definition that you must use the complete quadratic equation? So meaning to say, from this equation, we need to find a we need to solve for the quadratic equation, or we need to find the complete quadratic equation first. So this gives us 2 over x plus 4, just rewriting the equation, x is plus 3. Now, as you can see, we have the fraction here. In solving quadratic equation, we need to remove the fractions first so that we can try to take the form of the complete quadratic equation. So how can we remove the quadratic equation from this term? The answer should be, we just need to multiply both sides with what is the value of our denominator, or what is the value of the denominator of the fraction. So in this case, the value of the denominator in our fraction is x. So meaning to say, we just have to multiply that, all of them, we need to multiply that by x. So that gives, so that we can um, remove the fraction form of our equation. So we just have to cancel this one. X, 2x, 2 over x times x, that can be canceled. The denominator can be canceled because this is equivalent to 2x over x, right? 2x over x plus 4x, 4 times x, that's 4x, is equivalent to x times x, that is x squared. 3 times x, that is 3x. So again, we can cancel this one. So we have now 2 plus 4x is equivalent to x squared plus 3x. So as you can see now, we just have to rearrange this one so that we can already come up with the complete quadratic equation. So from here, we have the x squared. So we need to move this one or equate our equation to 0. So we now have x squared plus 3x. Moving this one to the other side of the equation, we have minus 4x, and then minus 2. That is equivalent to 0. So we just have to equate that one to 0. So that gives us x squared, 3x minus 4x, that is minus x or 1x, minus 2 is equal to 0. Now factoring this one, so we have, for the factor of this one, if you try to calculate that, we have x minus 2 and x plus 1. So meaning to say we have two equations or two factors of our equation, and you also need to see for how much is your exponent. That is also the number of your factors. So since we have 2 here, or we have squared, meaning to say our equation also has two roots. So we have x is equal to 2 and x is equal to 1. Negative 1, that is negative 1. Because you need to equate this one to 0, right? From this one, again, I just have to rewrite that one. So from this one, x minus 2, from x minus 2, we just need to equate that one to 0. So to get the value of our x, we need to move our constant to the other side. So we have x is equal to 2. So from x plus 1, that is equated to 0. So that gives us x is equal to negative 1. Now, um, we have two roots, but the problem is looking for the solution set. Now, the solution set is different from the roots. If the solution set or the roots conforms or equivalent, if you check that one and it is equivalent to each other, meaning to say this side, again, meaning to say if this side is equivalent to this uh, side, that is one of the solution set. But if it's not, then you cannot call that one as solution set. So let's try to check this one first. If our x is equal to 2 and x is equal to 1 is our solution set. So by checking that one, we just have to substitute that back to our equation. So we have uh, x is equal to 2. We have 2 over 2 plus 4 is equivalent to 2 plus 3. So 1 plus 4, that is equivalent to 5. That is equivalent to 5 as well. So meaning to say, 2 is part of our solution set. Now at x is equal to 1, x is equal to negative 1, let's see if it is still a solution set. So we have 2 all over negative 1 plus 4 is equivalent to negative 1 plus 3. So negative 2, 2 divided by negative 1, that is negative 2, plus 4, that is positive 2, and negative 1 plus 3, that is positive 2. So meaning to say, 2 and negative 1 is our solution set. So in writing our solution set again, we need to enclose that one in a parenthesis. So we have negative 2, we have positive 2, and we have the negative 1. So this is now the solution set of our equation. So now we'll move on to, let's move on to the next method, which is, so we have now the extracting the square root method. So for the extracting the square root method, we have to, we just need to extract the square root, or we need to use the square root so that we can eliminate the power or the exponent, and we can find the value of our x. So for the example we have here, find the solution set of x minus 2 squared is equivalent to 10. So this is really easy. So again, we have x minus 2 squared is equivalent to 10. Now, as we know, in order for us to eliminate the exponent or the squared, we just have to square root both sides. So that is what we call the extracting the square root. So meaning to say we'll be using the square root method so that we can eliminate the exponent or the squared of our equation. So we have a square root and squared that can be cancelled. So meaning to say we have x minus 2 is equal to positive negative square root of 10. As we know, class, if we use the square root sign, that gives us the result of a positive and negative answer. So meaning to say, kung dili na siya ma-simplify, naa siya equivalent na positive, negative jud always. Always, the right side of our equation has two values already if you use the square root sign. Na siya, meaning to say na siya positive square root of 10, na po siya negative square root of 10. So for this one, in order for us to isolate the value of x, so i-move lang nato sa pika side ang ato ang 2. So we have x is equal to 2 plus minus square root of 10. This will yield to a decimal answer in which it will, if you use decimal points or decimal answer with decimal points, medyo hindi siya appropriate or hindi siya yung exact value. So for this one, since we cannot simplify this anymore into fraction or any number that is constant, we can just use this one. So meaning to say we have two roots now, which is x is equivalent to 2 plus square root of 10, and we also have x which is equivalent to 2 minus square root of 10. Now, we have to check again. Before we can say that that is already the solution set, we need to check if this term is equivalent to 10. So, by doing that, we need to substitute our values of x. So, we have 2 plus square root of 10 minus 2, and then that is squared. If you try to calculate that one, that should be equal to 10. If that is equivalent to 10, meaning to say it is the solution set of the problem. So if you try to calculate that in your own, that is equivalent to 10. So meaning to say uh, this one is a solution set of our equation. So when we try to substitute now this one, so we have 2 minus square root of 10 minus 2 squared is equivalent to 10. So for this one, again, this is still equivalent to 10. So meaning to say our factors or our roots is the solution set of our, this one is the solution set of our equation. So that gives us 2 plus square root of 10 and 2 minus square root of 10. So this is now the solution set of our equation. So now let's move on to another method, which is the quadratic formula method. So this is the most commonly used method that we already know since elementary, I guess. So I believe and I presume that all of you are already familiar with the quadratic formula method and you are already knowledgeable enough in applying this kind of method. So basically, we just need to find from our equation, we just need to find the value of our A, the value of our B, and the value of our C, right? So from the example, we have find the solution set of 8m squared minus 3m minus 1. So maybe you will be confused why I used another variable. This one, class, is just equivalent to the variable that you used in your equation. So meaning to say, our A is equivalent to from the form ax squared plus bx plus c, which is equivalent to 0, meaning to say this one is our ax squared, this is our bx, and this is our c, right? So meaning to say from that being said, we have a is equivalent to 8, we have b is equivalent to -3, and we have c is equivalent to -1. So from that, we already have the values of our a, b, and c, meaning to say we can already substitute that here in our quadratic formula. So that gives us m is equivalent to negative of -3, because our b is -3, plus minus square root of b squared, which is -3 squared, minus 4, and then our a, which is 8, and our c, which is -1. That is all over our 2 and our 8. So this gives us 3 plus minus 9. Negative times negative, that is positive. 4 times 8, that is 32. So we have 2 times 8, that is 16. So that gives us the equivalent of 3 plus minus square root of 41 all over 6. So this is now the result, or if you can still simplify this one, then you can do so. So if we try to simplify that one, that will give us a decimal points or decimal answers. So meaning to say we can just use this one as our roots. So meaning to say we have our roots as equivalent to 3 plus square root of 41 over 16. And we also have 3 minus square root of 41 over 16. So we'll try to check this one. If you try to check this one from our equation again, so at m is equivalent to 3 plus square root of 41 all over 16. Substitute that one to our equation. We have 8 times 3 plus square root of 41 over 16. And you square that one, minus 3 times 3 plus square root of 41 all over 16, and minus 1. If you calculate this one, this should be equivalent to 0, since our right hand side of the equation is equivalent to 0. So since I already pre-calculated this earlier, that this is equivalent to 0. So meaning to say, this factor or this root here is the one of the solution set of our equation. So if you try to calculate that one using the minus square root of 41, let's try. So at m is equivalent to 3 minus square root of 41 all over 16. So if you try to plug that into our equation, that still gives us 0 is equivalent to 0. So meaning to say, the solution set of our equation is 3 plus square root of 41 over 16 and 3 minus square root of 41 over 16. So this is now the solution set of our equation. Now let's try to move on to the last method. So we have here another method of solving quadratic equation, which is the completing the square method. So in completing the square method, to complete the square for your quadratic equation x squared plus bx, the steps below should be followed. First is find 1/2 of b, and the second one is square the value obtained in step 1. And the step 3 is add the result of step 2 to x squared plus bx. So for example, we have here Find the solution set of 2a squared plus 5a is equivalent to 42. So as you can see from here, this does not conform with this expression yet because as you can see, we still have the coefficient or we still have a value beside our a squared or from this one, this is our x squared. So meaning to say we need to remove this one first by what? We just have to rewrite that one. We have 2a squared plus 5a is equivalent to 42. Now, dividing that by the coefficient, we need to divide all of the terms by its coefficient so that we can isolate or we can get a squared here. So, divide all of that by 2. So, meaning to say we have a squared is plus 5 halves of a. 5 halves a is equivalent to 42 over 2. So, we have 42 over 2, which is basically equal to 21. So we can just write 21 instead. So afterwards, we already have the same format of this one. We already got the x squared plus bx. So we just need to follow the steps now. So we need to find, first is we need to identify what is our b. So from this equation, we have this as our b. So again, our b is equivalent to 5 halves. And it says here that we need to find 1/2 of b. So meaning to say we need to divide this by 2. And that gives us equivalent to 5 over 4. Afterwards, after we do this one, we need to do the step 2, which is square the value obtained in step 1. So meaning to say we need to square this one. So the result of this one is equivalent to 25. 5 times 5, that is 25. 4 times 4, that is 16. So mean to say we already have this. And then this is check. The next process or the last process is add the result of step 2 to x squared plus bx. So we just need to add that here in our equation. So that gives us a squared plus, we have a squared plus 5 halves a plus this one, 25 over 16. And we also need to add that one on the other side of our equation. So we have 25 over 16. Or this is already 21, right? So from that, we can already find the roots of this one by factoring this equation. So if you try to calculate that one, you can get the factor of our equation. However, to simply find the factor, class, there's a tip for you. Kung pila ang result sa pag-square or sa pag-divide nato sa ato ang b, you can just do that one or you can just have that one as your roots already. So meaning to say a plus 5 over 4 is already our roots. But since this is squared, you just have to square that one. So if you try to calculate that one, this will result to this. Okay? So 21 plus 25 over 16, that gives us 336 plus 25 over 16. So LCD. And afterwards, since as you can see, this is in squared equation, applying what you have learned earlier to get the value of our a, we just need to square root both sides, so we can eliminate our squared, and we can already find the value of our a. So that gives us a is equivalent to we will be moving this one to the other side, so that is minus 5 over 4. So we have positive, negative, This one 336 plus 25, that is square root of 361. And the square root of 16, that is 4, right? Minus the 5 over 4 that we move. We move this one to the other side of the equation. That's why that is minus 5, 4. So as you can see, we already have the roots of our equation. But since we just need to check that one first kung siya ba jud ang iyahang solution set. So again, we have A is equivalent to positive 361 all over 4 minus 5 fourths. And we also have A is equivalent to negative square root of 361 over 4 minus 5 over 4. So you can just check this one if that is, if you try to substitute that one here and it is equivalent, meaning to say these are the solution set of our equation. So I've already checked that one earlier, but it yields to the same answer, or 42 is equal to 42. So meaning to say our solution set is square root of 361 all over 4 minus 5 over 4 and negative 361 over 4 minus 5 over 4. So this is now the solution set of our equation. But if you can still simplify this one and still yields to a fraction form or fraction answer, then you can do so. But for me, it's fine for now. So now let's move on with we'll move on to the last topic, I guess, for this discussion. We have equations leading to quadratic equations. So the same with the linear equation, which we also have equations leading to linear equations. We also have that here in quadratic equation. So we have here, for example, solve for x raised to 4 or x to the fourth minus 13x squared plus 36 is equal to 0. As you can see, class, this is not a quadratic equation yet because the exponent or the highest number of exponent is raised to 4, in which for the quadratic equation, we just have to have the highest exponent of 2. But as you can see, we can still yield, or we can still solve this one because we can try to find a solution in order for us to transform this equation into a quadratic equation. So how can we do that one? How can we transform that to our to a quadratic equation? So basically, you just have to factor out, or just have to extract x squared from this. So that being said, we have x squared and squared, right? This is the same. X squared raised to square, that is equivalent to x to the fourth, right? So meaning to say, we've already extracted x squared from that. So that gives, we also have the 13x squared plus 36 is equivalent to 0. So class, you just need to let any values or let any variables that must be equivalent to x squared. So for example, we let u is equivalent to x squared. So meaning to say all the x squared in our equation will be replaced by the variable u. So from here, we have this one as x squared. So meaning to say that is u. But we still have another squared outside. So we have u squared minus our 13. Since this is x squared, meaning to say you can replace that by 1u. And then we also have the 36. Now, as you can see, this already yields to a quadratic equation. As you can see, we have the u squared minus 13u plus 36. That is already the same now with our ax squared plus bx plus c, right? This is our ax squared, this is our bx, this is our c. So meaning to say this is already in quadratic equation form. Now after you get this one, you need to find now the factor of this one, since we can already factor this one. If you try to solve that on your own, the factor is u minus 9, and we also have u minus 4. So you can try to calculate that one from your calculator. I hope you know how to factor that. So afterwards, again, we already have, we can equate this one to 0. So u minus 9 equal to 0. So u is equivalent to 9. And for this one, we also have u minus 4 is equivalent to 0. So u is equivalent to positive 4. So afterwards, as you can see, u is not yet the 9 and 4 is not yet the result of our, or not yet the roots of our equation. We need to go back to our values that we've let, meaning to say x squared is equivalent to 9. Since u is equivalent to x squared, meaning to say x squared is equivalent to 9. The same as here, x squared is equivalent to 4. Now, how can we find the value of our x from here? So meaning to say, you just have to square root that both sides in order for us to get the value of our x. Same as here, square root both sides. So we have x is equivalent to positive, negative. Square root of 9 is equivalent to 3, right? So meaning to say we have x is equal to 3, positive 3. We also have x is equal to negative 3. And for the other side, again, we also have x is equivalent to positive, negative square root of 4, which is 2. So we have x is equivalent to positive 2 and x is equivalent to negative 2. So as you can see, we have 4 roots, class, because as we know, our equation has also the power of 4, meaning to say this equation will also give us 4 roots. So in this case, our roots are 3, negative 3, 2, and negative 2. So again, you can try to, since you can try to substitute that one, each of these roots to our equation. If you get the value of 0 in every substitution you have, meaning to say those are the solution set of our equation. But in this case, the solution set of our equation is 3, positive 2, negative 3, and negative 2. These are all the solution set of our equation. So that gives us the solution set of this one. So if you are confused with the topics that was discussed in this video, you can don't hesitate to message me. Don't hesitate to ask me questions via messenger, via LMS, and you can also post a question in a forum that we have in our LMS. So those are all the discussions for this video, class. Thank you very much and have a great day.